Hi Professor, uh, it's me Jivan. Today I'm going to give you a live demonstration of the real-time data processing pipeline that I built on AWS for my project. The main objective of this project is to build a complete end-to-end system that uh, handles a continuous stream of data. Mm, the goal is not just to store the data but to process the real-time data, apply some logics, and then store only the results that matter. For my project, I chose the use case of bank trying to detect suspicious transactions that the moment they occur. mm, the, then build a scalable pipeline on AWS to ingest it, then process each transaction in real time to the business logic, that is in this case a fraud detection rule. Then store the highly priority flag transaction for analysis, and then lastly to visualize that data to generate actionable insights. For this I'm using the Cloud9 as my IDE, and in Cloud9 in my IDE I first made the bank data generator. I'm simulating 10 bank accounts for this, and the transaction types are deposit, withdrawal, payment and transfer, and you can see the merchants, and it generates the data of transaction types: withdrawal, deposit, and other payment or transfer. Now let's see if this generates the data or not. For this I'm opening the new terminal. For this one it's bank data generator.py. Yeah, it's working fine. After this I created the Kinesis data stream where it receives the data, and next I created a database table using DynamoDB. After that I installed Boto3 to send the generated data to Kinesis stream, and this is my Python running Python version. Then I made the Kinesis data center where it sends the data to the Kinesis stream. This is my transaction Kinesis stream. It's named as transaction stream. This function sends the record to the stream. Here I have selected the account ID as the partition key. After this I created the lambda function. This is my lambda function. It is configured to trigger automatically every time the new data arrives in the stream, and I'm using the business logic where it detects the fraud for the transaction type withdrawal. If withdrawal amount transaction goes beyond 2000, is my the fraud detection logic. If the condition meets, then it is printed as flagged, and this can be seen in our logs. And this is the trigger that I created. The state is enabled. I need to first deploy my lambda function. I'm deploying it. Yeah, it's successfully deployed. Now I'm going to my Cloud9 terminal and and using this operator I'm taking the output of my generator and feeding it directly as the input to my Kinesis sender. This creates a continuous live data flow. Oh, it's not working. I did a mistake. This is not my name. Yeah, the transaction is being sent. You can see the different accounts. Now going back to here and see, now to see the logs I'm going to CloudWatch. CloudWatch in log groups. Yeah, here is it. There is a trans. Here we can see the logs. Yeah, this is the log, and there are some transactions that is uh, seen as a flagged suspicious transaction detected for this account, and there is more to see if this data are stored in our table. Let's refresh this one. Here is my suspicious transaction table. Going to explore items. Here we can see the transaction that was flagged as the suspicious. You can see transaction type withdrawal, and the amount is exceeding $2,000, so it's kept as flagged and stored in our DynamoDB database. For monitoring and error handling, we have already seen the primary tool for monitoring, which is CloudWatch logs. It gives the complete visibility into every execution of our code. And for error handling, let's go through the lambda function code. In the lambda code, you will see my entire processing logic for the single record that is wrapped in try and except block. If the pipeline receives a malformed record, then this block will catch the error. It will log the error to the CloudWatch. For the visualization, since QuickSight was not working because of the permission issues, uh, I use visualization data Python file. This is the code that generates the bar chart, histogram, and time series plot. For this, I need to first install the library. Paste it. Install the Seaboon. Since it has been successfully installed, now run visualize data. Let's run it. Yes, now we can see the transaction by account, transaction over time, and amount distribution. Here you can see the visualized data, distribution of flag transaction by amounts and transactions by account, gather account numbers, transaction by accounts, and the transaction over time. So to summarize, I have just walked through a complete live data pipeline. I generated data, sent it to Kinesis, processed it in real time with Lambda, which I monitor with CloudWatch, then stored the valuable filtered results in DynamoDB using a schema designed for efficient sorting. That was my project 2. Thank you.